Mathematicians, we are in our last section of chapter 11. This is area of similar figures. Just a recap here of what we talked about yesterday in terms of finding the area of a regular polygon. I'm going to walk you through these and then we're going to move forward. So we know that the area is 1/2 times the apothem times the perimeter. So in this case, I happen to know the apothem, but I don't know the perimeter. So I know it's going to be 1/2 times 15 times something. So let's go ahead and figure out what that something is. So if I make a triangle, okay, I'm going to figure out how many sides this figure has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's an 11-sided figure. All right, so that means that this measurement is 1/22 of 360. So I'm going to take 360 divided by 22 is 16.36. So in this triangle, this angle is 16.36. And I need to use that to find that measurement. So I know the adjacent and I want to figure out the opposite. And so I'm going to take the tangent of 16.36 is equal to opposite over adjacent. So I'm trying to figure out this fraction piece right there. And then I can either double it to get one side length and multiply by 11, or I can just go ahead and multiply it by 22. So I'm going to take the tangent of 16.36 tangent times 15. And so that's going to be x is equal to 4.40. Okay. And then I'm going to multiply that times 22 because that's going to give me my perimeter, which is 96.87. So now I'm going to take that times 15 times 0.5. So the area is 726.55 units squared, right? Now with this triangle, I need to find this measurement again. 360 is the total of all of the angles. I've got this total angle here is 120, which makes this angle 60. And so when I take out my triangle, this is 30 because that is 60. And this is 6, so I need to figure out x. And in a 30, 60, 90 triangle, just a reminder, opposite 30 is x. Opposite 60 is x square roots of 3. And then opposite the 90-degree angle is 2x. So when I look at this, 6 is my x. So when I look at this measurement right here, that's going to be 6 square roots of 3. So the perimeter of this triangle, it's a regular polygon, so it's an equilateral triangle, is going to be 6 square roots of 3 times 6. So when I look at my formula, I'm going to take 1/2 times the apothem times 36 square roots of 3. All right. So 3 times 36 times the square root of 3. That is going to give me, you could either write it as 187.06, or if you want to be like super exact, you could do 108 square roots of 3. So again, kind of reviewing, how do we find the area of a regular polygon? Pulling a lot of mixture in. Okay, so now area of similar figures. Let's go to town with this. So if we have two figures that are similar, their areas are proportional. So when we look at this, the area of the bigger one compared to the area of the smaller one is equal to the length of mg squared over the length of AB squared. So it's the side squareds that are proportional to the areas. So let's take a look at this. the area of ABC. So we're going to say the area of ABCD is to the area of PQRS. And that's going to be equal to, let's see here, DC and RS. Here's RS. So then I'm going to say DC over RS, that quantity squared. And the reason why it's the quantity squared is because we're talking area. So if the area of ABCD is 48, so 48 over X is equal to 6 squared over 9 squared. So when I multiply that out, I'm going to have 81 times 48, and I'm going to divide by 36. So X is equal to 36. So the area of PQRS is 36 inches squared. Good times. All right, the area of ABC is 98 square inches. So I'm going to write out my formula. Area of ABC is to the area of RTS as, let's see here, let's see if these, so BC is, let's see here, BC will correspond to TS. BC corresponds to T. Yep, okay, I just had to verify that those connect. Is equal to BC over X squared. All right, so the area of ABC is 98. The area of RTS is 50, and that's equal to 14 squared over X squared. So 14 times 14 times 50. So 9,800 is equal to 98X. So the product of 50 and 14 squared is 9,800. Ooh, that's taking a while. There we go. And then when we divide by 98, 100 is equal to X squared. X equals 10. Right? So that's the value of X. So making sure we set it up and remembering that that squared goes to both the numerator and denominator. Okay. All right. What do we got here? The area of a skyscraper is 90,000 and the area of the model is 200. If the skyscraper is 720 feet tall over X, that equals squared. Just hear my dog. She's just like, oh, so tired. It's tough. Like, all right, here we go. So I'm going to say that 90,000 times X is equal to 200 times 720 squared. Ooh. Big number. 103,680,000. Right, divide by 90. So X equals 1,152. That doesn't make sense. That doesn't make sense. It can't be more. Let me try this again. 720 times 720 times 200. Did you see my mistake? Oh, kiddos, did you catch it? Oh, shops, I just got done telling you that the squared goes to both, and then I didn't do it. So X squared is equal to 1,152. So the square root is 33.94 feet. Inches, I got to use the right unit. Oh, goodness. Totally made a mistake. All right, we got one more here. Then we're going to be wrapping up Chapter 11. Here we go. The side lengths of two similar octagons are 14 and 22. The area of the smaller octagon is 120. What is the area of the larger? Okay. So the area of the smaller is 120. The area of the larger, we don't know. And that's equal to 14 over 22 squared. All right. So 120 times 22 squared is equal to x times 14 squared. So 120 times 22 times 22 is 58080 is equal to 14 squared, which is 196. And now I can divide by 196. So 58,080 divided by 196. So 296.33 is equal to x. Makes sense. That's the area of the larger one. All right. Have a fantastic afternoon, evening, morning, weekend, whenever you're watching this. Thanks for tuning in. We'll talk to you soon. Take care.